Good afternoon. My name is Gabriel Ostrowitsky. Today, I will be presenting a comparative analysis of two construction options for modernizing the HVAC controls in SE1, BCIT's electrical building. What if I told you that one building on this campus wastes $22,200 every single year? Here's what we'll cover. I'll walk you through the problem, present two viable construction solutions, break down the financials and feasibility of each, and conclude with clear recommendations for the philanthropist's $2 million investment. SC1 is located at 3700 Willingdon Avenue, a two-story, 15,000 square foot facility built in the 1980s. It houses 69 controlled spaces across 3 occupancy types. 23 assembly spaces like classrooms and the theater, 15 industrial labs and workshops, and 24 business areas including offices. Now here's the challenge. All 69 spaces are controlled by a single zone pneumatic system that's over 40 years old. The problem tells the story. 185,000 kilowatt hours of excess consumption annually. At BC Hydro's rate of 12 cents per kilowatt hour, that translates to 22,200 in wasted energy costs every year. However, beyond energy, service calls occur at 3.5 times the rate of comparable buildings. Labs reach 28 degrees while offices drop to 18. Equipment that should last 20 years fell in 12 to 14. And perhaps most importantly, these visible operational struggles contradict BCIT's reputation as an institution of technical excellence. The floor plan shows the complexity we're dealing with. 17 office spaces, 20 industrial areas, 3 design flow zones, and 29 classrooms totaling 69 distinct zones. The problem is clear, all 69 on a single pneumatic control. The solution requires an individual digital control for each zone. Let's examine our options. Option 1, a full building automation system retrofit. Option 2, a hybrid pneumatic to electronic conversion. Option 1 is a complete replacement of the existing pneumatic infrastructure with a network digital building. The project spans 8 to 10 months across 5 phases: design and engineering, equipment procurement, installation of each floor, and commissioning with staff training. The estimated budget is $1.6 to $1.8 million, well within the philanthropist's limit. With option 1, we propose a full building automation system upgrade. This includes digital controllers for all 69 zones, smart sensors, variable frequency drives, and a centralized dashboard for real-time monitoring. On the left, obsolete pneumatic actuators, a 40-year-old compressor system, manual thermostats with no scheduling and zero diagnostic capabilities. On the right, smart DDC controllers, efficient VFDs, connected wireless sensors, precise zone damper actuators, and a proactive BOCnet monitoring. Option 2 takes a different approach. It installs electro-pneumatic transducers at critical control points and programmable thermostats in high priority zones, but retains the existing pneumatic actuators and compressor infrastructure. The timeline shows a difference. Option 1 requires 8 to 10 months with phased floor-by-floor installation. Option 2 completes in 4 to 6 months. The hybrid is faster, but as we'll see, speed comes at a long-term cost. Now, let's assess the financial, technical, and operational feasibility of each option. Starting from our current baseline of 22,200 in annual energy waste, the full BAS delivers 25 to 40% energy reduction. That's 55,000 to 90,000 in annual savings, or 1.1 to 1.8 million over 20 years. Upgrading to a full BAS means more upfront cost and a longer project, but it delivers major energy savings, predictive maintenance, and individual zone control for every space. Over 20 years, it's the lowest total cost and best long-term value for SC1. The hybrid offers lower upfront cost and faster implementation, but long-term disadvantages are significant. Only 10 to 15-year lifespan, no predictive maintenance, continued pneumatic failures, and most importantly, a second major investment is still required at year 12 to 15. The full BAS costs more upfront but saves energy, lasts longer, and is the best value for SE1. As we can see, the total cost of ownership over 20 years favors the full BAS. My recommendation is clear: proceed with the full BAS upgrade. More but saves energy, lasts longer, and is the smartest investment for SE1. Thank you for your time. I welcome any questions. The following is a list of my references.